back to my channel, and today we will again discuss about magic squares. This is part 3 of the video. You can check out the part 1 and 2 in the I tab above. Okay, now we will talk about what transformations we can do in a magic square, and still the magic square will remain the same, right? The sum of all the rows, columns, and both the diagonals will be same, a constant. Okay, so this is the Wikipedia page about magic square. If you want to learn more about magic squares, you can find it more information from Wikipedia. Okay, so we will see the transformation that preserve the magic property. Okay, we will see the second point first. What does it mean? If you, the magic square remains magic when all of its numbers undergo the same linear transformation. That is a function of the form f of x is mx plus b. What does it mean is, let us see over here. We'll take a new page. Okay. So let us take a 3 cross 3 magic square. Okay. This is a 3 cross 3 magic square. Okay, I know the central number has to be 5. Then what we can do, 5 sum has the magic sum of every row is 15. I have explained it in part 1. You can check that out there, how the sum is 15 of every row, column, and diagonal. So this is a 5. Then sum has to be 15, so we have to make 10. So maybe 6, 4, and then here also the diagonal has to be, sum should be 10, 15, right? It is 5, so 10 more we have to make. So we can make maybe 3 and 7. Okay, and what we can fill over here, 6, 13, the sum is 13, we have to be 2. Then 7, 7 plus, this is 7, right? And 15 minus 7, 7's complement is 4, 3. Yes, no, it should be 8, right? We can fill in 8 over here. Let us see. If I fill 8, 8 plus 3, 11. Yeah, it's 15. 7 plus 4, 11. We have to fill again a 4. 7, 4, 11, 12, 13, 14. 4 more. No, we cannot fill like this. So we cannot fill 4 over here. Mm, let's check again. Let us fill 1 over here. If 1 is filled over here, then 5 plus 1 is 6, right? 6, 5 plus 1, 6, and 15 we have to make. So 6 and 15. 6 complement is 4. 5 plus 4, 9. Yeah, 9. So we can fill in 9 over here. Then we can fill it over here. Okay. So what do we fill over here? We'll fill 2 over here. 9 and 2. 9 and 2, 11. Right? 11 and 4. Okay. And then what we can fill? 3 we will go. 3 we will fill over here. Then 5 plus 3, 8. Right? 8 and 15. Oh, 2, 5, 6, 7. Yeah, so we can fill 7 over here. Then This is 3 plus 4, 7, right? And 7 and 15. 7's complement is, oh, it's 8, right? We have to fill 8 over here. 8 plus 1, 9. 9 and 6. So let's see, 6 plus 4, 10, yeah. 8 plus 2, 10, okay. 7 plus 3, okay, 10. Then 9 plus 1, 10, it's fine. Yeah, this is the magic square. It is satisfying all the properties. So we got the magic square. Okay. So this is an example of a magic square where sum of all the rows, columns and both the diagonals is 15. Okay. So what this second point was telling is, if you add, so we know that we will take the top row, we will look at the top row first. If in this whole matrix, if we add all the numbers by a constant, okay, we will add all the number, add by, maybe say 5, all the numbers we increase by 5. So what will happen? Okay, 3 3 cross 3. So means we are adding 5 to all the numbers, right? So we'll here fill 8 plus 5, 1 plus 5, 6 plus 5, 5, 3 plus 5, 5 plus 5, 7 plus 5, 4 plus 5, 9 plus 5 and 2 plus 5. All the numbers have been increased by 5. So this is a new magic square after the transformation. But note, I knew that the sum of 8 plus 1 plus 6, originally the first row, the sum was 15. 8 plus 1 plus 6 was 15. And to all the numbers you added 5. So that means 3 times you have to add 5 in this sum. And all the columns also. All the elements have been added by 5. So originally the sum was 15. Now you have added 5 3 times. The sum would be same. That would be 15 plus 5 into 3, 15. 30. The sum of all the rows and columns will be 30, and that it is restoring the magic square property that sum of all the rows, columns and diagonals is same, that is 30. Okay. Okay, then that was this part. Okay, plus b part. Okay, you were adding a constant. Now even if you multiply again, if you do the transformation, the next, this was the first transformation. Second transformation, you make a new magic square by what you're doing, multiplying all the numbers by a constant. Say we multiply all the numbers by 2. So what will happen? So you got a new magic square, and we have to check whether still the sum of all the rows, columns and main diagonals are same. That is the magic sum. So we multiplied all the numbers by 2. 1 into 2, 6 into 2, 3 into 2, 5 into 2, 7 into 2, 4 into 2, 9 into 2, 2 into 2. Okay. So what can I rewrite all the numbers? We will see the first row only, and same way you can check for all the rows, columns and the main diagonals. So first row I know 8 into 2 plus 1 into 2 plus 6 into 2. What you can do, you can take this 2 outside. So 2 into, we are taking this 2 common, 8 plus 1 plus 6. And I know 8 plus 1 plus 6 was 15, the original magic sum. That is 2 into 15, that is 30. And that will be same. Similarly, you can do for the first column also. It will be 2 into the original sum, right? So all the rows, column and diagonals, they are still preserving the magic square properties. Okay. So you can combine now both the operations. That means if you do one transformation instead of two, That is, you multiply all the numbers by 2 and then add 5 or any constant, still the magic square property would be preserved. Similar reasons. Okay. You can try it yourself. You can try to do first multiply by 2 all the numbers and then you add 5 to all the numbers. Still it will be a magic square. That is the first point being explained in this Wikipedia page. Okay. Now second, what it is saying, the sum of any two magic squares of the same order by matrix addition is a magic square. So it is saying if you have two magic squares, both are magic square, two different magic squares. And what you do is you add the same position elements together. Okay. So suppose in the magic square one, the elements were A plus B plus C is equals to the magic constant, and that constant would be suppose M1. Okay, and the second magic square, the first row's elements are x plus y plus z is equals to another constant m2. Okay, and it is written that you have to take the magic squares of same order. Means if you are taking the first magic square is 3 cross 3, then second magic square has to be 3 cross 3. Okay, same order has to be there. Now if you add, means you add a and x in the new magic square, what you are doing is you're adding the first elements, the second elements and the third elements. So what will happen? Your new element is a plus x, this is the first element, plus b plus y, this is the second element, plus c plus z, this is the third element, is equals to, now I know a plus b plus c was m1 and x plus y plus z was m2. So that will be equal to m1 plus m2, and that will be same for all the rows, columns and diagonals. So still your magic square properties are retained, that all rows, columns and diagonals, their sum is same. Okay. Um, and another important thing is written over here, that if every element in a normal magic square of order n is subtracted from n square plus 1, the complement of the original square is obtained. Okay. What does this mean? Okay. I know in the first part we discussed how the sum of natural numbers, n natural numbers was calculated. Okay. So we will revisit over here. What does this n square plus 1 means in a magic square, where the size of the matrix or magic square is n cross n. Okay. So let us take the example where n is equals to 3. That would be easy to understand. So if your n is 3 or 3 cross 3 magic square is there, you have a 3 cross 3 magic square. How many elements will be there? From 1 to n square, that is 9. That is sum of 1 to 9 natural numbers, right? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Correct? So what does n square plus 1 means? Now if you see the complements 1 and 9 and 1, the first and the last, their sum is same as n square plus 1. N is 3 over here, right? So their sum is n square plus 1, that is equal to 10. Correct? 9 plus 1, 10. Similarly, 8 and 2 also, their sum is 8 plus 2 is also 10. 7 plus 3 is also 10. Okay. So what you do, if to the all the elements of the magic square you subtract from n square minus 1. Over here it will be 10 minus 8, right? 10 minus 8, 10 minus 1, 10 minus 6. So what will happen? 8's complement is 8's complement means if you're looking at 8, so at the same position from beginning the number is 2. So you will get a magic square where 8 will be replaced by 2, 1 would be replaced by 9, right? So from the beginning and ending, same position element would be replaced in the new magic square, and still the magic property would be retained. Okay. So that means if we find the complement, or you can see over here the example given over here. The example over here is of that of a 4 cross 4 magic square, and the 4 cross 4 magic square numbers will be from 1 to n. 4 square is 16, and the sum would be, magic sum would be 16 plus 1, that is equal to 17. So if what you do, if you subtract 17 from all the numbers over here, so what will happen? 10 minus 17 minus 10 would be 7. So, and 10 and 7 are equidistant from beginning and end. Okay, that is the meaning of complement square. And still, these two magic squares are still having the same magic sum. Okay, okay. So let us move ahead. Now, what does this point say? A magic square remains magic when transformed by any element of D4, the symmetry group of a square. Okay, okay. The dihedral group of order 8. Okay, it is very easy. It is not very hard. What it is saying is, if you take the magic square, any magic square, and you create new magic square by just taking the mirror image of this magic square. Okay, you took the mirror image. Look over here. Mirror image taking means this first column now became the third column. This third column now became the first column. And the numbers are exactly same. Only the rows are same, the numbers are same, the positions of the rows and columns have been changed. So still these two are magic squares, right? But they are not identical. Similarly, if you rotate this square, this original square, if you rotate by 90 degrees, rotate means you you hold both the corners of this page and you just rotate by 90 degree like this. So that means what will happen? This first row, this first column now becomes the first row, correct? Yeah, this one. Okay, 8 3 4. Now this, when you hold, imagine holding this page and just rotate by 90 degrees. Okay, okay, not this one, this one, 438. Okay, so 438, cause this column 438 will become the first row, and then this 951 will become the second row, 276 will become the third row. Still the positions of the rows have been changed, but the elements and placing are exactly the same. So still it will hold the magic square properties. Okay. Now again, if you rotate this original square by 180 degree. Okay. Earlier we rotated it by 90 degrees. Now if you rotate by 180 degrees. Okay. So what will happen? Still the magic square properties would hold over it. Okay. Or if you by diagonal also, you keep the diagonal same and you just flip the elements, still the magic square properties would hold. If you flip it, what will happen? 852 will remain the same. 4 will come over here. 6 will go down, right? And yeah, 1 will come over here. Yes. You just keep this diagonal same and flip like this. Okay. So you will get this. And still the magic square properties are true over here. Okay. So let us move to the next point, what it has been explained over here. It is talking about the, if you do the same transformations to both the rows and the columns of a magic square, then also the magic square's property would stay intact. All the rows, columns and diagonals would still have a same constant magic number sum. Okay, what it is meaning? So let us see the meaning of this transformation. This transformation, what it is saying is, first row. Okay, this notation means it is a permutation transformation. Okay, so you can write this like this. Your input was 1 2 3 4. Okay, we need a bigger space. Okay, your input was 1 2 3 4 5 6. Okay, this was your input. Now your 1 will be placed at position 4. Your sixth row will be position, your second row will be shuffled to sixth position. your third row, original third row would be shuffled to fifth position. Your original fourth row would be shuffled to second position. Original fifth row would be shuffled to first position. Original third row will be shuffled. Original sixth row would be placed at third position. Okay. So first on this rows, what we are doing, you are applying this transformation. Means the fifth row would come to the first position. Okay. The fifth row comes to the first position. The original sixth row will come to the third position. Okay, this is 1, 2, 1, 2, 3, 4, 5, 6. Okay, and let us try to make it on our sheet. We will just take this matrix. Okay, this was our matrix, and we will place this also on a new page. Okay. Okay. So if we recreate this magic square, 6 cross 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So original first row. This was the original first row. We will place it at fourth row. 1, 2, 3, 4. We will place it over here. 1, 32, 33, 4, 35, 6. Okay. Original second row we will place at sixth position. Okay, this was the second. 30, 8, 27, 28, 11, 7. Okay. Original third row we will place at fifth position. 13, 23, 22, 21, 14, 18. Okay. And then we have come till third row, right? Third row. Then original fourth row, we will change its position to second row. So 24, 17, 16, 15, 20, 19. Then original fifth row we will put in the first position. So 12, 26, 10, 9, this is 26, then 29, then 25. And the sixth row, original sixth row, we will place at third position. 31, 5, 3, 34, 2, 36. Okay. What we have done, we have applied this transformation on all the rows. Okay, we got this. Okay. Here the sum of rows will still be a magic constant, the original magic sum. But the sum of the diagonals will not be the same. Okay, because diagonals have changed. Look, 1, 8, 22, 15, 29, 36. Here the same diagonal is not present. See, look at the diagonal. It is not the same. Both the diagonals we will check. So originally this was the diagonal. Okay, we'll just erase a little bit. See, in one diagonal, 1 is there and 1 is 31 is there. So here, in this diagonal, 1 is not there, right? 1 is not there, neither 31 is there. So diagonal sum might have changed, actually have changed. But rows and columns, their sum would be still magic sum. Now what we have to do on this same in this transformed row transformed magic square, if you apply same column transformation, this transformation, same symmetric transformation on the columns, then you will get the sum of the diagonals also as the magic sum. Okay, so we will apply it on the columns. That means first column will be mapped, this first column would be mapped to fourth column. Okay, okay, first, second, third, fourth, fifth, and sixth. 1, 2, 3, 4, 5, and 6. Okay, the first column, this was the first column, you have to place it at fourth column, right? 12, 24, 31, 1, 13, 30. The second column will go to the sixth column, 26, 17, 5, 32, 23, and 8. Okay, then third will go to fifth, 10, 16, 10, 16, 3, 33, 22, 27. Okay, then fourth column would go to second column, fourth, right? 1, 2, 3, 4, 9. Yeah, 9, 15, 34, 4, 21, 28. And then fifth column will go to the first position, 29, 22, 35, 14, 11. And the sixth column would go to the third position, 25, 19, 36, 6, 18, and 7. So now note the main diagonals, right? So I, so this would be the diagonal. See, 1 has been included in the main diagonal. Let us check this diagonal and the original. 1 is present, 8 is present, 22 is present, 15 is present, 29, 29 is present, and 36, 36. So this diagonal sum is same as the original magic square, but only the positions have changed. And the second diagonal also we will check. This is the second diagonal. Okay, see, 6 is there, 6, then 11, 6 is there, 11, 11 is there, then 21, 21 is also there, 16, 16 is also there, 26 is also there, 31, 31 is also there. So what is written over here is, see, the 29 has come first, 29, 20, 29, 22, 35, 29, 22, 35, 40. Exactly same magic square we got. So what is written over here? So any transformation you do on the rows, if you do the same transformation on the columns as well, then the resulting new magic square will also, new matrix will also be a magic square. Okay, so the why this is true, its answer is you will get if you study group theory. Okay, that I'm not explaining over here, so we will discuss that in future videos sometime. Okay, hope you like this video. Please share it with your friends and subscribe to my channel, and we will meet in the part 2 of transformation properties of a magic square uh, in future video. Bye and take care.